During World War II, Henry Ford built a factory in Michigan that produced a bomber every single hour in 1944 for over a year. Think about that for a second. A 60-foot aircraft with over 1 million individual parts coming off an assembly line every hour of the day. That level of coordination, engineering, and execution is almost hard to comprehend. And in a lot of ways, that's where modern manufacturing really began. I wonder what Henry Ford would think about the current state of the assembly line. We'll ask our guests about that and much more coming up. Today, I'm joined by Mark Walter, project manager at Leidos. He has a background in engineering and large-scale energy projects for the automotive industry. We're going to break down how energy is actually used inside automotive plants and how these projects are managed from idea to execution. If you're responsible for a building and want to stay ahead on operations, vendors, and systems, subscribe. That's exactly what we cover here. Enjoy the show. Hey, Mark, welcome to the podcast.
Thanks for having me.
We just got through some technical difficulties. Luckily, you're an engineer, so you figured it out. These programs they try and make them user-friendly, but then sometimes not so much.
Yeah.
Well, thank you for coming on. So why don't you tell us a little bit about how you got into engineering and project management?
Yeah, so currently I'm a project manager for a company called Leidos Engineering, who's a large Fortune 500 technology company. It's one of those big companies that unless you're in the industry, you've probably never heard of it. But that's where I'm currently at. I've been in the energy space since I graduated school in, I think, 2014. And when I was going to school, unfortunately or fortunately, I looked at it like a business decision, and I decided to pick a degree that I felt like would be in demand to help me pay for school, right? Which unfortunately is what I think a lot of kids are having to do now, make those tough decisions. And I went into a new field called environmental studies, and I actually got an emphasis in sustainable engineering. So at the time, there was a big push for renewable energy, energy efficiency, everything along those lines, because we saw the writing on the wall that energy is going to continue to get more and more expensive, and it's going to become very important for industry. So that's kind of how I got into this space.
And that's funny now. The energy question's even bigger with AI and data centers and things like that. That wasn't. I mean, data centers were around when you were in college, but not quite to this extent, I think. So it's
Yeah,
interesting.
yeah. I think back then, if you asked 100 people what a data center was, they would, maybe 20% of them would even have any idea. And now it's on the news every single day, so it's definitely
Right.
changed a lot.
Right. So more recently, you've been working with automotive plants.
Mhm.
What type of projects are you heading up there?
Yeah, so our main customer is large industrial customers, specifically automotive plants. Um, Most recently, the push has been eliminating steam from these facilities, right? Automotive in the United States is obviously a really old industry, and a lot of these plants, they're so big, right? They're 5 million square feet, 4 million square feet, and their sole job is to make vehicles, right? So a lot of times their infrastructure kind of gets put on the back burner for new robots and new cutting edge technology to make the vehicles because that's what makes them money, right? So we're going into a lot of these facilities that were built in the 50s, 60s, 70s when steam was in its heyday, and they're still exactly like they were back then, right? And steam is a great energy user and a great way to move a lot of energy around a large facility, But when it's now, 50, 60, 70, 80 years old, it's not efficient technology anymore. So most recently, we've been going into those spaces and converting from a legacy steam system to a more modular, typically hot water boiler solution. And that's usually housed in their mechanical or their powerhouse. So we're doing a lot of powerhouse upgrades these days.
Interesting. And so where do you think these types of facilities are normally spending the most on energy? Is it steam? Is it water? Is it, electricity? What is their main driver there?
Yeah, so before I started with Leidos, I was actually an energy manager for one of these large automotive plants, right? So I kind of have some insight to this. Usually, when we look at where their energy is going, we're looking by department, right? So if you're thinking about an automotive assembly plant, for example, so this is where they bring in raw materials in one side of the building, and out the other side of the building comes your F-150, right? So they do everything from stamping to painting to assembly. Usually the largest energy user is the paint shops. So if you've never been in an industrial paint shop, they are they are huge operations, right? You have a truck or a car coming by and being painted every 5 minutes. So there's a lot that goes into that. There's the compressed air to run the paint guns. There's people working in those areas, so you have to get all those fumes out of the building, and you have to have fresh air coming in. So you have all that fan power, all the electricity to run that, and then you also have to bake the paint. So there's gigantic ovens that are burning natural gas. So usually, especially in a assembly plant, paint shops are the largest energy users for that
Even
facility.
more than the building systems themselves?
Yeah, yeah,
Wow.
especially if you look at like natural gas. And especially in the Midwest, right? If you think about an area for the facility, just like the typical things like heating, air conditioning, stuff like that, you're only heating for a couple months out of the year, right? So you might have a big demand for heating or January, February, March, but these paint shops are burning natural gas every single day of the year, right? So yeah, they're probably the biggest users.
Okay. What would you consider sort of the biggest wastes that you see as far as, energy consumption goes in this type of facility?
Ooh, that's a good question.
Like,
It,
is there something that you walk in and you're like, "Oh, that's not right. I could change that, upgrade it, make it work
yeah,
more efficiently."
Yeah, this is something you won't catch right away when you walk in, but when you get to understand a large building, whether it's an industrial building or a commercial building, like most of the people that you deal with are probably in, like a high rise. Once you understand the inner workings of the building, it's like an organism, right? I mean, if you got a 50-story skyscraper, there's so much that goes on to that. Once you understand it, you find so much waste in just the way things are operating. Right? So they call this operational energy savings. So this is something like, the janitor comes in every Saturday and runs this mop sink for 7 hours because he forgets to turn it off, right? That's a huge energy waste and it's really easy to find. So on a grander scale, when we go into these big buildings, you'll be walking around a multi-million square foot facility and you'll find a pump running that's not connected to anything, or a big fan running that's not providing any useful benefit to the plant. So those operational savings, you might not find them right away, but those are like the low hanging fruit. Don't take any money to fix, but it takes some time and understanding of the building and system to find them.
Um, let's talk a little bit about the energy efficiency projects that you mentioned that you headed up, whether it's lighting, retrofitting, um, controls and automation upgrades, maybe operational changes. Tell me a little bit about these projects and what kind of ROI the customer might experience and sort of how to track that project.
Yeah. So it used to be like the standard companies were looking for was like a 2 to 3 year return on investment for energy projects. And you could do that, 10 years ago pretty easily in a building where, you take really old, inefficient lighting systems like high pressure sodium, which are those big, like orange light bulbs you see in like an old school gymnasium. They had that really high pitched, like hum to them.
Hmm.
Um, and you could replace those with LED and you could probably pay back in 2 to 3 years all day. Just because they're so much less energy, they were relatively cheap, and utility companies were offering big incentives, right? So this is another field I used to work in where, in our area, ComEd, right? They would give a building money to do something efficient, right? So if they were doing an LED lighting project, it might have been a 5-year payback, but ComEd gave them X amount of dollars and brought it down to a 2 or 3 year payback so they could get that work completed in a reasonable time. Um, Now, these days, unless you're in a really old facility that has never had energy efficiency as a priority, you're probably looking at, on average, like a 5-year payback for a lot of these major, energy projects, and those are projects that are really gonna move the needle. So those are projects you're gonna see in your energy bill. You can still find those 2-year and less projects, but they're usually not big needle movers for your facility.
Hmm. So we're sort of in phase two of our, as a society moving towards more efficient, energy consumption. Um, the people that did not catch up, with the first wave, um, still have to make those changes. So that's interesting. Um, what's sort of a quick way to calculate, energy savings? Whether there's people listening that might be working in a small facility. What's a quick tip? Good way to look at these things.
Yeah, so some systems are really easy to calculate energy. So the typical system that's really easy is like lighting, right? And then you can get to more complicated systems like boiler systems or water cooled chillers, and they take a little bit more calculation and effort to do that. But they fundamentally all start the same way. You develop your baseline, right? So your baseline is, what is your system doing now? How many hours is it operating? How much energy is it requiring? And you develop that baseline, and then you develop your proposed solution, and you say, hey, with this new equipment, this is the energy portfolio that we think is going to be consumed by that equipment, and you compare the two, right? That's a really simple explanation to your question, but nowadays there's so many resources out there. There's the Association of Energy Engineers. There's a organization called ASHRAE. There's all sorts of literature out there on how to calculate savings. There's also a lot of tools, right? So you can go in there and say, I have a 50 horsepower motor. I want to put a VFD on it, and it will tell you how much energy you're going to save. And with AI, it's become so easy. As long as you understand what your system is and how it's operating, you could plug it into one of the 10 AI models and get relatively close
Hmm.
to understanding what your energy savings would be.
Yeah, there's almost like no excuse anymore. Um, there's no knowledge gap, or I mean, there is. You have to spend the time to do the research, but the information's out there, and we're all working with pretty much the same tools. Which some time ago, maybe only the Fortune 100 companies had access to, the best information and the best consultants. But now everybody's, for the most part, on an equal playing field when it comes to tools. Um,
Yeah. I think the biggest gap is I find that a lot of these companies, right, the environmental and the sustainability team is at like a corporate level, right? So if you're a building manager and your building's owned by JLL, right, there's a corporate energy team that's guiding, the organization on what to do. But there's a big gap between those people in corporate energy and the people who actually do the work, like the facilities managers, the operators of the powerhouse. Those are the people you really need to interface with because they can tell you, hey, I've had this idea to change the control system on our air houses, but I never had any money to do it, or I've never had any guidance on how to get it completed. And if you don't have that connection between the environmental and the energy team and the actual people running these buildings, that's the biggest gap in this whole thing.
You may have touched on it a little bit already, but what does an energy audit look like, and what what type of um, feedback is a customer going to get from someone like you that comes into their facility?
Yeah, so there's governing bodies that talk about energy audits. There's level one, level two, and level three energy audits. And a level one is could be as simple as I get on the phone with somebody, hey, tell me about your facility. What are your users? Maybe send me a couple bills. And then they just get more and more involved from there. So level two and then a level three. Um, Typically, what I've done in the past is, right, we'll have a pre-call, especially if it's a brand new facility we're not aware of, and we'll talk to whoever's leading the charge from their team, and we'll want to get people involved that are boots on the ground. So we'll ask them questions like, how much do you spend a year in utilities? What projects have you done in the past? Have you identified any projects currently? Are there any constraints based on, the product you produce, right? If you need if you're making microchips and you need the building to be exactly 68 to 69 degrees Fahrenheit for some of your process, right? We're probably not going to mess around with your HVAC system, right?
Hmm.
Because it's more important for you to keep making those microchips than it is for you to save on your electric bill. So once we kind of get that preliminary stuff, maybe get some pictures from the site, we usually come to the facility and we'll walk around with the team and we'll look at your big hitters. So for your audience, let's use a like a high-rise building, for example, right? So high-rise building, their energy profile is very different than an industrial setting. So we might be looking at their lighting system. We're going to definitely be looking at their HVAC, which is like their air conditioning, their heating, their ventilation system. And then we're going to be looking at uh, their central utility complex or their mechanical room where their chillers are, their boilers are, their hot water heaters. And we're going to walk around, we're going to talk with the operators, and we're going to basically inventory all your equipment that's there. And then we bring that back and we look at best practices to try to offer suggestions on ways to improve what you have. So at the end of that audit, you might get a list of 50 different ideas on how to save energy. And every one of them will save you energy, but some of those projects are going to be a, 20-year payback. We're
Right.
going to tell you like, hey, there's all these things. If you had unlimited funding, this is what we could do. But realistically, we're going to throw away 90% of these. And these are the three projects you need to focus
Hmm.
on.
Because it's about what fits into their business model and their output. What they're producing, or what the focus is in the facility. Um, do you think facilities are over focusing on buying new equipment when maybe the real opportunity is in, like, how to run leaner with what they already have?
Yeah, that's a good question. So it depends on the facility, right? If this was a facility put in, let's say less than 10 years ago, and all their equipment is 10 years old, most likely they don't need to rip out all that stuff and put in new equipment, right? They really should be on day one when that equipment goes in, prioritizing how to efficiently and properly run that equipment. And that something we haven't talked about, but there's a process called commissioning. So if a new building goes in, they install these new complex systems. A lot of times those complex systems go in and they get them running just enough to do what they're supposed to do, right? So if
Hmm.
we put a boiler in a building, that boiler will run and that will make hot water. But is it running the exact way it's supposed to? Is it running within the design? Is it running efficiently? So commissioning comes in and makes sure it's actually running to design and it's running at a max efficiency. That is a great thing to do because from day one you can ensure you're not wasting energy. But now if you're in a building that's 50, 60 years old, a lot of that equipment's at the end of its useful life. So we wouldn't advise you to put a tremendous amount of money into a system that only has 5 years left. right? When you get to that age of equipment, it's usually best from a sustainment of the asset and from a financial aspect to replace that equipment or replace it in phases, right? Because you're not going to have enough money to replace all this major equipment, but build out a plan to get your equipment back up to current operations through probably buying new equipment. And in that plan, bake in energy efficiency into it.
In manufacturing, uptime is huge, making sure that we're pushing out cars or microchips every day. Otherwise, we're losing money, right? How does a contractor like you have to, what is it like working around these, these parameters to keep everything moving?
Yeah, you got to do it very carefully, especially with us being in the energy space. Like I said, everybody wants to save energy, but they don't want to do it to the hindrance of their product. So it takes a long time to build a culture of energy in your facility. And one bad project that has a negative effect on production can ruin that entire culture. It could have taken you 5 years to get an energy project going, and the first one you do is bad and it stops them making, F-150s. You're going to spend another 10 years getting them to let you do another project, right? So that's something we're always thinking about is how can we do an energy project without the people who are running production ever knowing we did the project? Um, so that's really difficult, especially in some areas like automotive paint shops are very hard to do work in because it really is an art to paint a car. There's so many different variables, the temperature of the air, the humidity, how the air moves, and it evolves every day. So if you go into a paint shop and you make a change and something happens to the quality of that paint, it's it's really hard to ever do a project in there again. So that's something we're always thinking about is how can we do a project that does not affect the core business?
Yeah, and having buy-in from everybody on the team, from someone who's down on the floor doing a process to, someone at an executive level who's overlooking the numbers. It seems that that culture point that you brought up is huge. Someone down on the floor can absolutely decide that last time we did this, it was no fun and this or that happened. Um, so when you guys go into starting a project, is there, does it take a lot of convincing and a lot of showing how it's going to be done? Or is it more of a numbers thing? Like, um, here's what it's going to cost, here's how long it's going to take, and this is what we need to do? Or is it more like process, like we got to shut this area down and then do this work? What approach do you guys end up taking usually?
Yeah, so it's definitely the numbers piece, like what is the ROI on that project? But we have to identify early on in the development of that project if it's going to have an effect on production. And if it's going to have any effect on production or satisfaction of your tenants, if you're running an office building, that needs to be a discussion before the project even gets developed, right? Because if we're doing a project in a hotel and we say, hey, your tenants are going to be hot for 3 days because we're doing this in July and you're going to have no air conditioning, that's going to be a non-starter. When we need to know that before we put effort into developing that project and before we get people at our customer excited about that project, and then they find out that it's never feasible to begin with. So that's a conversation we need to have with all the stakeholders very early on in that discussion.
How big of a role do contractors play in projects in, the auto industry versus them completing projects in house?
Yeah, so it depends on who the automotive customer is. Um, some of the older automotive customers, they have pivoted to we make them vehicles really well. We want our team to focus on making vehicles. Everything else that's auxiliary to making vehicles, like energy efficiency, facility management, housekeeping, the plowing snow, all that type of stuff that you still need to do to run a facility, but it doesn't directly affect vehicle production. Contractors play a huge role because they'll say, "Hey, Leidos, you guys know energy efficiency, you know automotive, you guys are the experts in that. We'll continue to be experts in building vehicles. You help us out with this small piece of our business, which is energy efficiency." So it is huge for those types of folks. Some of the newer up and coming automotive customers, we're finding that they're trying to keep a lot of that work in-house. So they'll have full architectural and engineering firms. They'll have full resources available to, you know, design, execute, and engineer these projects all in-house. But they might still bring in a company like us to give them guidance and help do an energy audit and things like that. But there really is a big mix across different types of customers.
Hmm. What do you see as, what are some of the variables that can cause a project to not go well, in the eyes of the, the factory?
Yeah, I think the biggest thing would be poor communication is a huge one, right? You need to have a solid communication plan. You need to identify all your stakeholders and how they need to be involved. Because if you say, Matthias needs to be involved in this project, but he only needs to be involved in the first, 10%, you need to make sure you involve Matthias during that first 10%. Maybe he doesn't have to follow the project all along, but identifying stakeholders and communicating is the most important part, because if you're executing a project for a customer that is, annoyed with you because they don't know what's going on, or they don't have confidence in your guys' abilities anymore because, maybe we shut down a piece of equipment during the week and it had an effect on something because we didn't communicate with them and they didn't communicate with us that that piece of equipment was important, that will derail a project very, very quickly, and you'll still get that project done. It just it won't be as easy, and it won't be as fun, and it won't be as enjoyable to execute.
Right. I wanted to ask you about solar as well. Do you see any of, probably more in the newer automotive plants, are they using solar at all to power their processes and their facilities?
Yeah, I don't deal a lot with solar in my day-to-day job, but I know about it from my educational background. It's funny you mentioned that. Rivian just announced, it was on their LinkedIn profile last week, that they're doing a big joint venture with a solar firm, and they're putting, I don't remember how many megawatt hours of solar, but a large amount of solar on their building. And one of the problems with solar has always been, well, what if it's really sunny that day and you don't have a need for that much power? And what do you do at night, right? So battery storage is really what needs to go along with solar. And Rivian, just like Tesla, are in a unique position where they have a bunch of batteries, right? They might make a battery and it doesn't pass some standards, so they can't put it in cars. Or, they might have had a car that's been on the road for 5, 6, 7, 8 years. That battery needs to be replaced. That battery still works. It just doesn't work well enough for your Rivian, right? So I didn't read the full article, but I think what Rivian is doing is they're using old or decommissioned batteries from their vehicles, and they're going to build a big battery bank at their assembly plant. So they kind of solve that storage issue. So they're going to get energy from their solar system to help offset their electric at their plant, and then they're also going to charge up a battery bank to help offset electric during non-solar hours. It'd be an interesting read for folks to go look into. I really got to look into it in more detail. People are doing solar. Solar is hard to do on the scale of projects I work on. Like, a lot of our customers are spending $1 million a month on electricity. You have to have a really big solar farm to do that, and you need a lot of space, right? That's another big constraint. if you have a big assembly plant in the middle of downtown Chicago, you're going to have nowhere to put these things, right? But yeah, solar's come a long way. Personally, I think solar's great, but we really need to prioritize investing in storage, whether it's battery storage or hydro storage or some new storage system that's yet to be discovered. I think is the big keystone piece with solar.
Yeah, I was talking to my brother-in-law about um, electric vehicles, and I can't remember what model of car it was, and I hope I'm not misspeaking, but he has a dental office and, his home, right? And this car could potentially charge and collect energy at one and go and take it to the other. And let's say the power goes out at home, your car could potentially um, back up the energy usage for your house. Is that true, or am I just making stuff up?
Yeah, that's true. Like, I'm sure a lot of cars do this, but the Ford Lightning is always advertised as it could be like a backup home generator,
Yeah.
right? So if your power goes out, you could backfeed your house from your car. Um, but that brings up a very interesting discussion that's been going on forever is how do we integrate electric vehicles into our grid so they're not just pulling from the grid, but they can also put into the grid. And that becomes a never-ending discussion on is our existing electrical infrastructure ready for that? Because
Hmm.
this is something I looked into quite a bit at school and after, and then I kind of lost touch with it. But the idea of, if you ever heard of like a microgrid, so like my neighborhood would be on its own electric grid and it could be modernized, it could be up to date. We can have a little solar farm in the back field, we can have a little windmill, it can all serve us. And then with electric vehicles, if we all had electric vehicles, right, we're all sitting at home right now. If we all had Teslas or Rivians, they'd be sitting at home. If I had solar on my house, let's say it's a beautiful sunny day, I'm not using all that solar electricity. I can pump it into my Rivian or my Tesla. And then at night, that Rivian or Tesla, when my solar goes down and I'm not using my car, it's fully charged, it can put that energy back into my house. Or at a grander scale, if you had a microgrid, all of my neighbors could Rivians and Teslas could put that stored energy back into our neighborhood. Um, that's another thing right now is our grid, and this isn't my specialty, but our grid really needs modernization for the next wave of energy changes that are coming.
Hmm. Yeah. Um, Back on the facilities side of things, um, data is easier to process and collect than it ever has been before. Um, how are facilities, collecting data from their processes or from the facilities operations, and then, how do you guys go about interpreting that?
Yeah, so there's a broad range of how much data or customers have and how they're collecting it. It could be something as simple as their operator or their electrician goes around every day with a clipboard and writes down how much water's in this tank, how long has this pump run, how much steam have we used, and a lot of times there'll be 30 years of clipboards full of really great data, but nobody does anything with it. And when you come in, like somebody like me, to do an energy audit, that data is available and it's great, but it's really hard to process, right? If it's just on, pencil and paper, you got to put that all in a spreadsheet or somehow get that information in a usable form so you can run an analysis on that data. So I'd say a lot of people do that even still. Um, the next step up from that would be like maybe they have an iPad, right? And they're still collecting that data manually, but they're putting it in a digital system. That's great. It's not the most efficient way to do it, but it's cheap. You just have to have an operator walk around, they input some data, they put in an Excel sheet. Great. If you now you have that data in a usable form, but the next thing is what do you do with that data? Data is great to have, but if you don't do anything with it or you don't know what to do with it, it's just numbers, right? It doesn't do anything. Um, the next level up, which is where we try to get a lot of customers, is metering. So just like a meter on your house, right? You get an electric bill. you should be metering your major energy users at least as they come in the building, right? So you should have a meter on your water, your electric, your natural gas. And then down from there, right? If you think about your energy coming in, you should then go to the main branches, right? So my electric comes in, I think 50% of it goes to process A, 50% goes to process B. You should put sub meters on that equipment so you understand it, right? So if you say, hey, process A and process B are the exact same thing, but process B is using 30% more energy, that should be a trigger for somebody like, hey, let's look at that, figure out what's going on.
Mm-hmm.
So if you use data right, it can almost be like a map for you and your energy, I guess I'll say journey to
Mm-hmm.
pinpoint where you should be looking and then validate that what you did is actually saving you
Mm-hmm.
money.
When it comes to budgeting, do customers of yours generally say, hey, this is what we've allocated this year to these initiatives? What can you do within that? Or is it sort of the other way around where it's like, hey, we have this problem to fix. How much is that going to cost? And then go from there.
It's sometimes a little bit of both. I think most major corporations, especially those that have a public energy goal, they have an allocated amount of money every year that they can spend on energy projects. And when I say energy, I also mean water, just so you know. Um, but as a contractor, we don't always get told that, right? They might just say, hey, come in and tell us what we could do. And we just use our expertise to figure that out. Or they could say, hey, we really want to focus on our chillers this year, develop a project for us. And then we can go to them and say, hey, it's going to cost, $600,000. And they could tell us whether or not it's in their budget. And maybe it's not. And maybe they say, okay, we don't have room for that. Go look at the lighting system on the 15th floor. And that's kind of a challenge, right? Because if we at least know roughly what we're working with, we could tell you right away if something's going to fit in that budget or not. But it takes a lot of relationships and trust with your customer for you always to get that budget up front. Because the last thing they want to do is say, hey, I have $1 million to spend and I don't know who Mark is and I don't know what kind of work Mark does. And now all of a sudden, conveniently, my lighting project costs $1 million when it could be done for 600,000.
Mm-hmm.
Right. So there is people that come in and do that. So you don't always get the budget up front.
Do This is kind of a fun question. Do contractors get teased by the plant if they show up in a different brand of vehicle, or are the parking lots so big that they would never find out? You know what I mean?
Yeah, it's a good question. So funny story, at one point I lived in Indiana and I worked for General Motors as a contractor. And I was like a resident contractor. That's the only place I went. They're my boss. The only thing I did was work there. And I had a Volkswagen Jetta and I could not drive that Volkswagen Jetta to the plant. I had to park in the foreign car parking lot and I had to walk, I think it was like 35 minutes from the parking lot to my desk. And then when I was in the plant, I would have to walk to all these meetings and like the body shop and the paint shop. I would walk like 6, 7 miles a day.
My gosh.
So yeah, they do that. Most of the big three, like Stellantis, Ford, Chevy, as long as you drive one of the big three, you can go wherever you want, right?
Mm-hmm.
I always hear stories about people that have been in this industry for a long time, especially like in Detroit, where the UAW is really strong, where they would hear stories of people driving their Honda Civic and they get their tires slashed.
Wow.
Um, yeah, I've never experienced that. I don't know how
Yeah.
true it is. But whenever I go to a customer and I rent a vehicle, I always try to get that manufacturer's vehicle to show
Mm-hmm.
up.
Yeah.
So
Yeah. When you're at the rental counter, you're making
yeah,
requests.
yeah.
That's
There's a
funny.
note in my enterprise account that says must be GM or American vehicle. So
Okay.
yeah.
Yeah. The Detroit car culture is very strong. I'm sure people know about the history, but if you don't know somebody from that area, you don't really understand how much they love their cars and how much pride they have in those vehicles. I know I drive a Toyota and I show up to family and, everyone's polite, but everyone knows that their car is better than mine. You know what I mean? It's
Yeah.
a quietly understood thing.
Yeah.
or,
Yeah.
or that I'm supporting foreign enterprises,
Yeah.
which I don't really sit down in the beginning of the year and think, what, you know, companies am I supporting with my dollar necessarily that closely. So,
Yeah. It's always funny. I've had these conversations with people and it'd be like, okay, well, you're driving a Chevy Spark. That's made in Mexico or Korea. And my Toyota Tundra is made in, I think, Texas. It's like just because it's an American company doesn't mean that vehicle's made here. And just because it's a Japanese company doesn't mean that vehicle's not made here. I think the Toyota Tundra at one point had the most American parts on it of any vehicle. I don't know if that's
really.
still true, but yeah, that was their whole way to get into the truck market was just basically make everything here because
Hmm.
Americans love trucks and they love American trucks. So yeah, it's an interesting dilemma.
Have you had the opportunity to go to a plant overseas
I have
or
not.
in
I
another
have
country?
not. I would love to go to like Korea. There's a lot of
Hmm.
car manufacturing in Korea. I've been to California. I've been to Kentucky, Indiana, Michigan, Missouri. I think that's about it. But a
Hmm.
lot of the car manufacturers are like one area.
Yeah.
So
Yep. Great. This final segment here is the rapid fire segment. Couple fun questions here to take us home. What is your favorite brand of tools?
I've listened to all your podcasts so far. This is a very common answer, but Milwaukee. And I don't know if just because their branding is great, so everybody likes Milwaukee, or because it's a Midwest thing. I don't know if everybody you've looked at's from the Midwest, but
Yeah,
Milwaukee is probably the best, in my opinion.
I think there's some partialness to the Midwest. I think there's also, it seems like they have a large suite of tools where some of the other brands are a little bit more niched.
Yeah,
I don't know.
but it's a
Um,
good question. I work with a ton of trades, so pipe fitters, millwrights, electricians, and even within the same company, like a contractor I work with, I think all their mechanical has maybe Makita, but all of their electrical has Milwaukee. So it's like it's the same company, but electricians like Milwaukee and the pipe fitters like Makita, and some of them hate what they have. They bring their own tools, and yeah, people get really into it.
yeah, I know it's a fun question because you get to hear kind of what people are into, Um, the you don't have to tell us specifically where this took place, but do you have a most satisfying project that you've completed?
Um, yeah. So my first project with Leidos was probably my favorite, and it's because, like when I said, when I worked for General Motors as that contractor, I was the energy manager, and I developed this project with the GM team. And then when I got hired from Leidos, I got hired to run that job. And that was a big steam elimination job at a 5 million square foot facility. We put in all new boilers. We put new chillers in, air compressors. It really moved the needle for the energy at the plant. And it was also really cool. We put in a heat recovery system, which is something we didn't get to talk about, but it basically captures waste heat and it uses that heat to do something useful. So we actually make hot water to heat the plant in the wintertime, and then in the summer, we take that hot water and through an absorption chiller, which is a whole nother topic of its own, we convert that hot water into cold water and we cool the plant. So that was probably my favorite project. The site won a couple of awards for that project, which was really cool. And it was just good to see it all the way from development to execution. So that was probably my favorite.
Great. Um, Coffee or energy drinks?
So coffee, I was a road warrior for like 2 or 3 years. And when I was doing that, energy drinks all day. If you're driving a long trip, it's hard to beat like a Red Bull when you're driving. So
Yeah, the high is high, and then
yeah,
there's a bit of a crash.
yeah,
It's nice as the energy drink is there for like the last push of the day. I feel like, I mean, I see some guys at 7-Eleven, they buy like three
yeah.
monsters, and I'm like, what are you doing today?
Breakfast, lunch, and breakfast, lunch, and dinner.
Yeah. When you walk into a building, it could be a Target, or it could be a commercial high-rise Class A facility. What immediately stands out to you?
So the first thing I want to look for is, where's your big equipment? I like industrial. I like big equipment. I like stuff like that. So I'm usually saying, bring me to your powerhouse, bring me to your mechanical room, and let's look for some old stuff.
Mm-hmm.
Because big old stuff is usually what I look for.
Nice. You want to start wrenching on stuff.
Yeah. Yeah. It's funny. I was telling my wife, I want to take my dad to one of the steel plants in Gary has like an industrial museum where you walk around the abandoned steel plant. And I
It
thought
was the
that'd be the
largest in the
most,
world at the
yeah,
time. Yeah.
largest in the world. And I thought it'd be an amazing thing to do. And she's like, why the heck would you want to go look at a bunch of old, rusty, infrastructure? And I just think it's cool.
Yeah.
Yeah.
It's impressive. And speaking of impressive, Henry Ford did some impressive things to the automotive industry back in his time. His processes are still alive to this day. What do you think he would have to say about the current state of the assembly line system and auto manufacturing as a whole?
Yeah. At some level, I think he would be amazed that we're so much has changed in the way that things happen, but his general philosophy of the assembly line has basically been unchanged, right? It's still basically the exact same assembly line he thought of, just a lot more fancy things bolted onto the side of it, right? So instead of a guy there with a hammer, there's a robot. So it is kind of crazy to think that philosophy has been unchanged for so long. So yeah, I think he'd be pretty amazed that we're
Yeah.
still kind of doing things the same way, but so differently.
Mm-hmm. Well, Mark, thank you for joining the show and breaking down how engineers like yourself have such a huge impact on maintaining and keeping up our built environment. I appreciate you coming on.
Yeah, I appreciate you having me. We'll do this again, and maybe we'll focus on a specific building type that a lot of your audience and customers are spending time in, and we can
Cool.
dive into that.
Sounds like a plan. If you enjoyed this episode, make sure to like and subscribe to the Facility Focus podcast, and we'll see you next time.
Thanks.